Welcome. In this video, we'll explore the most essential Java Stream API interview questions, perfect for professionals with 3 to 10 years of experience. The Stream API is a powerful feature introduced in Java 8, allowing developers to process collections of objects in a functional style. We'll use a practical employee class example throughout, so you can see how these concepts apply in real-world scenarios. Whether you're preparing for your next interview or just want to deepen your understanding, this guide will help you master the key topics and techniques that interviewers love to ask about. Let's start by introducing the employee class, which will be our main example. This class contains fields like id, name, age, salary, gender, department name, city, and year of joining. It's a typical representation of an employee in an organization and is perfect for demonstrating Stream API operations. By using this class, we can cover grouping, filtering, sorting, and more. Understanding the structure of this class is crucial, as many interview questions revolve around manipulating such data models using streams. Work with streams, we need a collection of employee objects. We initialize an array list and add several employees with various attributes. This setup allows us to perform a wide range of operations, such as grouping by city or department, filtering by age, and calculating statistics. Having a diverse list helps us demonstrate the full power of the Stream API in handling real-world data scenarios. Common interview question is how to group employees by a single field, such as city or age. Using the Stream API, we can easily group employees by calling the groupingBy collector. For example, grouping by city helps us see how many employees are in each location, while grouping by age can reveal workforce demographics. This operation is not only useful for interviews, but also for real-world analytics. Another frequent question is how to count male and female employees in the organization. With the Stream API, we can use grouping and counting collectors to achieve this. By grouping employees by gender and counting the results, we quickly get the number of males and females. This technique is often used in HR analytics and is a favorite among interviewers. Taking it a step further, you might be asked to find the count of male and female employees in each department. This requires nested grouping, first by department, then by gender. The Stream API makes this straightforward with grouping by collectors. This operation is essential for understanding diversity within departments and is a great way to demonstrate your mastery of nested collectors. Interviewers often ask how to print all distinct departments in the organization. Using streams, you can map the department field and use the distinct method to filter out duplicates. This is a simple yet effective way to demonstrate your understanding of stream operations and data extraction. Filtering is a core feature of the Stream API. For example, you might need to print employee details for those older than 28. Using the filter method, you can easily select employees who meet this criterion. This operation is widely used in interviews to test your ability to apply predicates and extract relevant data. To find the oldest employee, you can use the mapToInt method to extract ages and then apply max. This is a classic use case for stream reduction operations. It's a common interview question that tests your ability to aggregate data using streams. Calculating the average age of male and female employees is another popular interview topic. With streams, you can group by gender and use averagingInt to compute the average. This demonstrates your ability to combine grouping and aggregation in a single operation. For more advanced grouping, you might be asked to calculate the average age of male and female employees in each department. This involves nested grouping and averaging. The Stream API's flexibility makes this possible with just a few lines of code, showcasing your ability to handle complex data structures. Another frequent question is how to count the number of employees in each department. By grouping by department and using the counting collector, you can quickly get these statistics. This is a practical example of how streams simplify data analysis tasks. To find the longest-serving employees, you can sort the list by year of joining and pick the first entry. This is a great way to demonstrate your understanding of sorting and selection using streams. It's a common scenario in HR analytics and interview questions. Sometimes, you need to find the longest-serving employee in each department. This requires grouping by department and then finding the minimum year of joining within each group. The Stream API's grouping and min-by collectors make this task efficient and concise. To find the youngest female employee, filter the list by gender and then use min with a comparator on age. This demonstrates your ability to combine filtering and aggregation, a skill often tested in interviews. A classic question is identifying which department has the highest number of employees. After grouping and counting, you can find the entry with the maximum count. This is a practical example of combining multiple stream operations for business insights. Sorting is a fundamental operation. You might be asked to sort employees first by name, then by age. Using comparators and the sorted method, you can easily achieve multi-level sorting. This technique is essential for organizing data in a meaningful way. Calculating the average and total salary of employees is a common business requirement. With streams, you can use summarizing double to get both values in one go. This operation is efficient and demonstrates your ability to perform statistical analysis using streams. For more detailed analysis, you might need to calculate the average salary by gender within each department. This involves nested grouping and averaging, showcasing your ability to handle complex data relationships with the Stream API. To find the employee with the highest salary, sort the list in descending order by salary and pick the first entry. This is a straightforward yet important operation, often used in compensation analysis and interviews. Finding the second highest salary is a classic interview challenge. After sorting by salary in descending order, you can skip the first entry and pick the next one. This demonstrates your ability to manipulate streams for ranking and selection. For even more flexibility, you might be asked to find the nth highest salary. By sorting in descending order and skipping entries, you can retrieve any rank. This is a great way to show your understanding of stream pipelines and advanced selection. Printing the top 3 highest salaried employees is a common business need. After sorting by salary in descending order, you can use the limit method to get the top 3. This is a practical example of combining sorting and limiting in streams. Beyond employee data, you might be asked to find the first non-repeating character in a string. By grouping characters and counting their occurrences, you can filter for those with a count of 1 and pick the first. This demonstrates your ability to apply stream concepts to different data types. Sorting by multiple fields is a common requirement. For example, you might sort employees by department and then by salary. Using chain comparators, you can achieve this easily with streams. This technique is essential for organizing complex datasets. Sometimes, you need to sort by salary in descending order and then by name. By revering the comparator and chaining with then comparing, you can customize the sort order to fit any requirement. This is a valuable skill for handling advanced sorting scenarios. In real-world applications, you might need to merge 2 employee lists and remove duplicates based on employee ID. By concatenating streams and collecting into a map keyed by ID, you ensure uniqueness. This operation is crucial for data integration tasks. Sometimes, merging requires custom logic, such as combining fields from 2 employees with the same ID. By providing a merge function in the toMap collector, you can control how duplicates are resolved. This demonstrates advanced stream usage and problem-solving skills. Another common question is finding the first non-repeating string in an array. By grouping strings and counting their occurrences, you can filter for those that appear only once and pick the first. This technique is useful for both coding interviews and practical applications. The Java Stream API is a favorite topic in coding interviews, especially for mid to senior level roles. Interviewers use these questions to assess your ability to process collections, perform aggregations, and write clean, functional code. Mastering these patterns will set you apart from other candidates. One of the key advantages of the Stream API is its functional programming style. This approach leads to more concise, readable, and maintainable code. By chaining operations like filter, map, and collect, you can express complex data transformations in a clear and efficient way. Collectors are a central part of the Stream API, allowing you to accumulate elements into collections, maps, or summary statistics. Understanding how to use collectors like groupingBy, counting, and averaging is essential for tackling most interview questions involving streams. A common conceptual question is the difference between map and flatmap. While map transforms each element, flatmap flattens nested structures. This distinction is crucial when working with collections of collections, such as lists of lists. The optional class is often used with streams to handle cases where a result might be absent, such as finding the maximum or minimum. Understanding how to work with optional is important for writing robust and error-free code. Parallel streams allow you to process data concurrently, potentially improving performance for large datasets. However, they should be used with care, as not all operations are thread-safe. Interviewers may ask about the pros and cons of parallel streams. A stream pipeline consists of a source, intermediate operations, and a terminal operation. Understanding this structure is key to building efficient and readable stream-based solutions. Interviewers may ask you to explain or design pipelines for specific tasks. Stream operations can be stateless, like filter and map, or stateful, like sorted and distinct. Knowing the difference helps you understand performance implications and how streams process data under the hood. Short-circuiting operations like find first and limit can terminate a stream pipeline early. This is useful for performance optimization, especially when you don't need to process the entire collection. Java provides specialized streams for primitive types, such as int stream, long stream, and double stream. These are more efficient for numerical operations and avoid unnecessary boxing and unboxing. While the Stream API is powerful, it has limitations. Streams cannot be reused once consumed, and some operations may not be as efficient as traditional loops for small datasets. Being aware of these limitations helps you choose the right tool for the job. Common mistakes with streams include forgetting terminal operations, misusing parallel streams, or misunderstanding lazy evaluation. Being able to identify and avoid these pitfalls will impress interviewers and improve your code quality. To get the most out of the Stream API, follow best practices like keeping pipelines short, using method references, and avoiding side effects in intermediate operations. These habits lead to cleaner, more maintainable code. In real-world projects, the Stream API is used for data processing, reporting, and analytics. Mastering these techniques will not only help you in interviews, but also in your day-to-day work as a Java developer. We've covered a wide range of Java Stream API interview questions, from basic grouping and filtering to advanced sorting and merging. Understanding these concepts will give you a strong foundation for any coding interview and help you write better Java code. To further solidify your knowledge, practice these patterns with your own data models and explore more advanced stream operations. The more you use the Stream API, the more natural it will become. Good luck with your interviews and happy coding.